Hi students, having found the constants of motion, let's relate them to the orbital elements. Let's start from the eccentricity vector. Let's take the dot product of the eccentricity vector with itself and expand this. The first term in the right hand side is the square of the modulus of L cross R dot. Now because L and R dot are perpendicular, then L cross R dot is equal to LR dot, which is equal to LV. So if we subtract 1 on both sides, now for the second term in the right-hand side, we can use again the vector identities of the triple product to write r hat dot r hat L cross R dot is equal to L dot R dot cross R hat. And R dot cross R hat is equal to R dot cross R vector over R scalar, which is the negative of the angular momentum. So this is equal to minus L squared over R. So we can write that E squared minus 1 is equal to 2 L squared over mu squared times V squared over 2 minus mu over R. So the quantity between parentheses in the right-hand side is the energy. We can then isolate the eccentricity. So this gives the eccentricity in terms of the energy and the angular momentum. Now let's use the definition from the previous class, so that L squared over mu is equal to the semi-major axis times 1 minus the eccentricity squared to find the relationship for the semi-major axis. Now if we square the eccentricity in this equation, and if we now substitute this expression for 1 minus E squared into this, we find an expression for the semi-major axis. The angular momentum cancels out, and you find that the semi-major axis is equal to minus mu over twice the energy. So on both of these equations, you have a geometry on the left-hand side and physics on the right-hand side. These equations synthesize the combination of Kepler's laws, which are empirical, with Newtonian physics, explaining the causes of the motion. The semi-major axis depends on the energy alone. Now, eccentricity is set by a combination of the energy and the angular momentum.